Welcome to our comprehensive tutorial on implementing face recognition technology in public transport systems. In this video, we will explore the complete pipeline from data collection to deployment, including all the necessary code snippets. So, let's get started. First, let's understand what face recognition technology entails and how it can benefit public transport. Face recognition can enhance security measures, streamline boarding processes, and even provide personalized services to passengers. Now, let's dive into how we can implement this. Before diving into the code, we need some necessary libraries. For this tutorial, we will use OpenCV for image processing and face detection, and a deep learning model for recognizing faces. Ensure you have these libraries installed in your Java environment. Next, we need to set up our project. Create a new Maven project and ensure the dependencies are included in your pom.xml file. This structure will allow us to handle packages efficiently and manage our libraries. Now let's create a class that will handle our face detection. We'll begin by initializing the OpenCV library, which is crucial for processing images and detecting faces. The detectFace method will implement the logic to detect faces in an image using our HAR Cascade classifier. Inside this method, we will convert the image to grayscale and perform face detection. Next, we will implement face recognition using a pre-trained model. First, we need to load our model and create a method to predict a person's identity based on their face. In the predict identity method, we will resize the image to match the model's input shape and convert it to a tensor format before predicting the identity. Now, let's tie our detection and recognition functionality together in a main class. This class will act as the entry point for our application. Next, we hone in on optimizing our system for real-time face recognition using live video feeds from public transport. We need to integrate video capturing with our face detection logic. As we process each frame, we need to draw a bounding box around detected faces to visualize detection. This will help in debugging and verifying our detection system. Once we have the face detected, we can apply the face recognition method to identify the person. Also, don't forget to add a proper exit mechanism for your video stream. Now that we've successfully implemented face recognition for public transport, let's discuss how we can improve this system further. We could enhance accuracy by using more advanced models like MTCNN for face detection or fine-tuning existing models on a large dataset of passengers. Additionally, ensuring data privacy and ethical use is paramount. We must build our system with proper data handling practices and compliance with regional regulations related to data protection. To summarize, in this tutorial, we covered the implementation of face recognition technology in public transport systems using Java. We went through detecting faces, recognizing identities, and processing video streams in real time. If you found this video helpful, please give it a thumbs up and subscribe for more programming tutorials. Leave any questions or suggestions in the comments below. Thank you for watching, and happy coding!